Divisibility rules. Divisibility rules, it says here, are rules that help us know whether a number can be divided by certain numbers. And we're going to discuss rules here for the numbers 2, 5, 10, which I think you'll already know. And then rules for the numbers 3, 6, 9, and 4. There are also a couple of rules for the number 8. I don't propose to discuss those today. Feel free to look them up elsewhere if you like. You might find them useful. I think perhaps not right now. So quickly, I think you know a rule for whether or not numbers can be divided by 2. The rule is all even numbers can be divided by 2 with no remainder. A number can be divided by 2 if it's even. And what are even numbers? Even numbers are numbers that end with 0, 2, 4, 6, or 8. All numbers ending with those numbers are even, so 30 is an even number. 72 is an even number, 124 is an even number, 76 is an even number, 498. Those are all examples of even numbers, and they can all be divided by 2 exactly, with nothing left over. Numbers ending with, for the 5 times table, numbers ending with 5 or 0 will all go exactly, yes, 5 will go into them without any remainder, because the numbers in the 5 times table go 5, 10, 15, 20, 25, and you can do the rest, can't you? And it goes on like so. And as you can see, all those are all numbers that end with either 5 or 0. So, as it happens, every number in the whole of our number system that ends with 5 or 0 is divisible by 5 exactly, with nothing left over, with no remainder. And for the number 10, you know, I think already, that all numbers that end with a 0 can be divided by 10. So 70 is in the 10 times table. 100 is in the 10 times table, isn't it? 10 tens are 100, going up to say 10 squared sometimes. 350 is divisible by 10. 7,298,720. That's a multiple of 10. These are all numbers that you can divide by 10. Those are rules I think you already know. Let's start talking about the ones we possibly don't know so well. 3. I've chosen 3 biggest numbers, and we're going to divide them all by 3 first of all to see if they'll go. The first one is 75,891. Let's see if we can divide it by 3. I've written it out over here. Some of you call this a cage, some of you call it a bus shelter. Call it what you like. Here's how we set it out. We'll do it, rather than try to do it in our heads, we'll write it down. So 7 divided by 3. Does 3 go into 7? Yes, it does. How many times? 2 3s are 6, so it's 2, remainder 1. I'm going to put my remainder in front of the next digit in my bus shelter. 15 divided by 3. How many 3's go into 15? 5, with nothing left over. Then we've got 8. 8 divided by 3 goes twice, remainder 2. That leaves you 29 there. Does 3 go into 29? Yes, it does. It goes 9 times, because 9 3's are 27. So we've got a remainder of 2 again. I'll carry that across to make 21. And 3 goes into 21 7 times exactly, with no remainder. So this number, yeah, absolutely. Let's try the next one. 47,622. 47,622. Practice saying those numbers yourself, by the way. Let's divide it by 3. 4 divided by 3, 1 remainder 1. 17 divided by 3, 5 remainder 2. 26 divided by 3, 8 remainder 2. 22 divided by 3, 7 remainder 1. 12 divided by 3, 4. Hey, it goes again. There we go. Another number that goes exactly. And finally, what's that number? Yep, 16,903. 16,903. Let's divide it by 3. 1 divided by 3 doesn't go, does it? No 3's go into 1. I've still got that 1 left over, so I carry it across to make 16. 16 divided by 3, 5 remainder 1. By the way, feel free to pause the video whenever we do these calculations and do them yourselves, and then just check if we've got them right by playing the video on. 19 divided by 3, 6 remainder 1. 10 divided by 3 is 3 remainder 1. 13 divided by 3 goes 4 with a remainder of 1. I'll write the remainder like that. We won't worry about it now. The important thing is that there is a remainder, so in other words, 3 does not go exactly into that number. Is there something about the first 2 numbers that we can identify that is not present in the third number? Because if there is, then that will give us a rule that we can follow that will help us know whether or not a number can be divided by 3. Well, actually, yeah, there is a rule. What we're going to do is we're going to add up all the digits in each of these numbers. So, let's clear this out the way a little bit. Great, okay. Add up all the digits in this number. That means we've got a 7 and a 5 and a 8 and a 9 and a 1. 7 and 5 is 12. 12 and 8 is 20. 20 and 9 is 29. 29 and 1 is 30. Let's do the same thing with the next number. 4 and 7 is 11. 11 and 6, 17. Plus 2, 19. Plus 2, 21. So those digits add up to 21. And let's check the last number. 1 and 6 is 7. 7 and 6, 16. 7 and 6 is not 16. Yes, it is 16. Beg your pardon. Plus 0, plus 3 is 19. So those digits add up to 19. Now, if you know your 3 times table a little bit, you'll notice something here. What do you know about 30 and 21? It is true about them, but not true about 19. Well done. Well done. This number and this number, 30 and 21, are both in the 3 times table, aren't they? Whereas 19 is not. And that tells us, or confirms, possibly, that there is a rule for the 3s, and the rule is this. If you have a number, like we do here, a big number, and you want to know whether 3 will go into it, what you do is you add up the digits, and if the sum of the digits, that's what you get when you add all the digits together, that plus that plus that plus that plus that, if what you get is a number in the 3 times table, like it was in the first two, and like it wasn't in the last one, if the number is, if the total is in the 3 times table, that means the number will be as well. It is something about numbers that are in the 3 times table is that when you add all the digits together, the number you get, the total, is in the 3 times table itself. So if the sum of the digits is in the 3 times table, the number will be. If the sum of the digits is not in the 3 times table, the number will not be. That's the rule for the 3s. Okay, now then, 6s is interesting. Let's look at the 6s. You'll like this. It's really simple. If you understand that rule for the 3s, you're in business. Here's the 3 times table. 3, 6, 9, 12, 15, 18, 21, 24, and so on. And underneath that, here are some numbers in the first few numbers in the 6 times table. 6, 12, 18, 24, and so on and so forth. And when you write it out like that, you notice something about the numbers in the 6 times table. First of all, they're all even, aren't they? And they're all in the 3 times table as well. And what that means then is that if you have an even number that is in the 3 times table, it will also be in the 6 times table. Think about it. After 24, you've got 30, haven't you? That's in the 3 times table, isn't it? 10 3s are 30. After that, you've got 36. That's in the 3 times table, isn't it? 12 3s are 36. And all the numbers in the 3 times table that are even numbers will also be in the 6 times table. So if you want to find out if the number's in the 6 times table, first of all ask yourself, is it an even number? So here's one that definitely won't be. 1,733 definitely won't be, will it? But here's one that might be. Let's check out this one. Let's do 32,100. Cool, let's do it. First of all, is 32,100 an even number? Well, yes it is, because it ends with 0, doesn't it? And that means it's even. Okay, second test. So, is it even? Yes. Second test. Is it in the 3 times table? How do we check? We add up the digits, that's right. So, what do we got? We got 3 plus 2 plus 1, and a couple of zeros. What is 3 plus 2 plus 1? 3 plus 2 plus 1 is, of course, 6. And is 6 in the 3 times table? Yes, it is. Therefore, the number will be. So, in other words, this number, 32,100, is an even number, and it's in the 3 times table, which means that it will also be in the 6 times table. You get a big fat tick. Here's another number. Let's rub this one out. 76,502. Is it an even number, we have to say? And is it in the 3 times table, we have to say? First of all, is it in the 3 times table? So, big one, is it an even number? Well, it ends with 2, and numbers that end with 2 are even, so yes it is. Secondly, is it in the 3 times table? Well, let's have a look. Add up the digits. 7 and 6, 13. 13 and 5, 18. 18 and 2, 20. Is 20 in the 3 times table? No, it's not, which means the number's not. Which means that this number, even though it's even, is not in the 6 times table. I'm going to move on now. But here's your simple two-stage test. Is your number an even number? If it is, it might be in the 6 times table. And if it's even, is it in the 3 times table? Add up the digits and see. If it is in the 3 times table and it's even, it'll be in the 6 times table. If it's not even, or if it's not in the 3 times table, or if it's neither, then it's not. There's the rule for the 6s. Well, let's move on to the 9s, because the 9s is very similar. Let's look at numbers in the 9 times table. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, 108, and so on. What do the digits add up to? 9, 2 and 7, 9, 3 and 6, 9, 9, 9, 9, 9, 9, 9, 18, 9, and so on. So we notice that all the numbers that are in the 9 times table have digits that add up to 9, or in the case of 99, 18, which is in the 9 times table. So the rule for the 9s is actually just like the rule for the 3s, which is you add up the digits, and if what the digits add up to is either 9 or another number in the 9 times table, like 18 or 27 or 36 or 45, then that number will be in the 9 times table as well. So we test a couple. Let's test 54,902, and let's test 27,405. One's even, one's odd, but that doesn't make any difference, does it? Let's add up the digits here. 5 and 4. 6 are here. Let's ask them to add this up for us. 5 and 4, Angus.
9.
Bravo. 9 and 9, Tom.
18.
18 and 0, Jack.
18.
Well done. 18 plus 2, mathematician,
20.
is 20. Is 20 in the 9 times table, Oliver?
No.
No, it's not. Therefore, the number's not in the 9 times table. Let's add up the next ones. 2 and 7, Danny.
9.
9 is right. 9 and 4, Zach.
13.
That was a hard one, you're right. 13 plus 0, George.
13.
Very good. And 13 plus 5, Matthew Holland. Well done. Is 18 in the 9 times table, Mr. Fung?
Yes.
It is, which means the number will be 2. That's the rule then for the 9s, just like the rule for the 3s, only the number has to be, the sum of the digits has to be in the 9 times table, not the 3 times table. Okay, good. And finally, a rule for 4s. Dead easy, this one. 4,016 is in the 4 times table, I'll tell you. 5,122 is not. Here's another one that is. 6,248 is, and 7,106 is not. And I'll tell you why that is and how I know for sure, because you don't need to worry about the thousands or the hundreds. If you just look at the last 2 digits and ask yourself, is that number in the 4 times table? Then that will tell you whether or not the whole number is. Is 16 in the 4 times table? Yes, it is. Is 22? No, it isn't. Is 48? Yes, it is. Is 6? No, it isn't. And that's the rule for the 4s. And the briefest of explanations as to why, here it is. 100 is in the 4 times table, isn't it? You can divide 100 by 4. 10 divided by 4. Benjamin.
2.
The remainder. Good boy, well done, under pressure. 20 divided by 4, Max.
5.
Well done. 25 fours make 100 exactly, which means that any number, any multiple of 100, like 4,000, or like 5,100, or 6,200, or 7,100, all these multiples of 100 will be definitely in the 4 times table. So you know that all the hundreds and thousands will be in the 4 times table. It's just the units and the tens you need to worry about. So if 16 is in the 4 times table, then you know the whole number will be. If 22 is not, then you know the whole number won't be. It's that simple. The rule for the 4s is a bit different to the 3s and the 6s and the 9s, in as much as you don't add anything up, you just look at the number that you have at the end, in the last 2 digits, the tens and the units, and if that number's in the 4 times table, then the number will be the whole number. If it's not, then the whole number won't be. And there are some divisibility rules. Feel free to go back through them for the numbers 3, 6, 9, and 4.